we want to see combinations with repetitions. Okay, I hope all of you hear me.
Yes, ma'am.
Yes. So we want to find out the number of ways of selecting a sample size of n from available R1 types of identical objects of type 1, R1 objects of type 1, R2 objects of type 2, RK objects of type K. Okay, for example, if I have 10 notes of rupee 1, 5 notes of rupees 10, 7 notes of rupees 50, and 5 notes of rupees 100, we are ignoring the numbers which are printed on the notes, so they are identical for us, and I want to select 5 notes from this. So in how many ways I can do this? And for this we are going to use certain theory. Okay, you should be able to identify the situation. You have R1 objects of type 1, identical objects. Okay, and the sample size is n here. So if I want to select 5 notes, then each type of notes should be available minimum 5 in number. Okay, if I have 4 notes only of rupees 10, how can I select 5 notes of rupees 10 then from that sample? I cannot, and therefore the sample size, if you are considering to be n, then you need to have minimum those many objects of each type. Okay, so what we are considering here, this is the formula we want to derive. Each Ri is greater or equal n. This is given to you. You want to select, or you want to find the total number of unordered samples, okay, of size n. So each Ri must be greater or equal n, and the answer is n plus k minus 1 Cn, which is same as n plus k minus 1 Ck minus 1, which comes from the property of combinations NCR is equal to NCn minus R. So one of them you can prove. Now what we are doing here, we are separating the k types by k minus 1 slashes. Okay, type 1, type 2, and so on, type k. Then we are putting stars. The number of objects we are choosing, those many stars we are going to put in each compartment. For example, if 2 objects are chosen of type 2, then we will put 2 stars in type 2 compartment. If we are selecting 3 objects of type 1, we will say put 3 stars in compartment 1. So we get a sequence of stars and slashes. Okay, are you getting up to this? We are getting a sequence of stars and slashes. And conversely, so thus we have a sequence consisting of how many stars? How many stars we are going to select? Can you tell me? What is the sample size? What is the sample size? Girls, do you hear me?
N star.
N stars. So we have a sequence consisting of n stars and k minus 1 slashes. So totally I am talking about n plus k minus 1 places, isn't it? Yes or no? How many places I am talking about? ये कितनी places हो गई बताओ मुझे ये. 1, 2, 3. This slash also gets counted when you count the places. 5, 6, 7, and so on, so on, so on. You have n stars and k minus 1 slashes. So totally how many places you are talking about? N plus k minus 1, isn't it? Are you getting this?
Yes, ma'am.
And how many stars you want to choose from these places? On how many places you are going to put the stars? इनमें से कितने स्टार्स होंगे बताओ. ये टोटल प्लेसेस हो गई आपकी. n plus k minus 1 are the places. On how many places you are going to put star out of these places? What is the sample size? देखो जितने ये स्टार्स आप डाल रहे हो इन सबकी एडिशन कितनी होने वाली है, 3 + 2 + so on +3. हाउ मेनी स्टार्स यू आर गोइंग टू पुट गर्ल्स? कितने स्टार्स होने चाहिए टोटल? n स्टार्स, है ना? हमने क्या कहा यहाँ पे, इन ईच कंपार्टमेंट वी put as many stars, as many objects are selected of that type, and total how many objects I want to select? I want to select total n objects, right? So how many places are available? N plus k minus 1. And how many places I am going to choose to put the stars? Out of these places, how many places I am going to choose? If you are not getting what I am saying, please ask me. Are you getting what I am saying? Yes or no?
Ma'am, K places.
How k places? Tell me. How many stars you are going to put?
N stars.
तो n stars के लिए कितनी places लगेंगी?
N places.
n places. How k places you will have? You will have to choose n places to put n stars out of n plus k minus 1. Do you understand this now?
Yes, ma'am.
Yes, ma'am.
हाँ. So here we are writing conversely. तो ये आ गया हमारा पहला argument. ये था that we get a sequence consisting of n stars and k minus 1 slashes put in a row, and conversely any sequence consisting of n stars and k minus 1 slashes in a row gives us an unordered sample of size n. अगर मैं sequence लिखूं directly तो वो sequence मुझे क्या देगा? Unordered sample of size n देगा. Okay, and therefore we are writing there is a 1-1 correspondence. There is a 1-1 correspondence between two sets. पहला सेट क्या है? Unordered sample size of n. And दूसरा sequence क्या है? n stars and k minus 1 slashes. Okay, got it now? I hope you have understood this now.
Yes, ma'am.
So last statement we want to write it quickly. Now the number of different sequences of n stars and k minus 1 slashes is exactly equal to number of ways in which k minus 1 slashes choose their positions out of n plus k minus 1 available positions. Do you understand meaning of this statement? Tell me. Suppose ऐसा है, there are 5 boys and 4 girls. So totally how many? And I want to make them sit for a photograph in a row. So in a row means 9 places hongi, right? I'm looking for an arrangement of 9 people. So if I'm choosing 5 places for 5 boys, then obviously it is same as choosing 4 places for 4 girls, isn't it? Are you getting me?
Yes.
Both will be same, no? Choosing 5 places for boys is same as choosing 4 places for girls out of 9 places. That's what we are writing here. We have 2 types of things now. Stars and slashes. Okay? Stars and slashes. So choosing n places for n stars out of n plus k minus 1 positions is same as choosing k minus 1 places or positions for k minus 1 slashes. And that's why, and therefore, so n stars के लिए आप कितने वेज में कर सकते हो? n plus k minus 1 सी n वेज में आप n stars पुट कर सकते हो, which is same as n plus k minus 1 c k minus 1. Do you understand this? Choosing n places, choosing n positions for n stars out of n plus k minus 1 positions is equal to choosing k minus 1 positions for k minus 1 slashes out of n plus k minus 1 positions. Do you understand this? Girls, do you understand this?
Yes, ma'am.
Only one or two typical students answer my questions always. Others are sleeping or what? And this doesn't look good on a recording. Okay? What I'm saying, you are making me to speak like this. Please answer. Yeah, let us have example of this so that you will have more clear idea. Right. The same example of notes we will continue. Okay. Write the question. A bag contains rupee 1, rupee 2, rupees 5, rupees 10, rupees 50, sorry 20, rupees 50, and rupees 100 notes. The notes of each denomination being more than equal to 5. Assume that the notes of each denomination are indistinguishable, means identical, indistinguishable. So we are not considering the numbers which are printed on the notes, okay? We are treating them as indistinguishable, and the order in which the notes are chosen doesn't matter. And the order in which notes are chosen does not matter. That means it is an unordered sample, okay? Find in how many ways five notes can be chosen out of the bag. find in how many ways 5 notes can be chosen out of the bag. So here you need to identify what is N and what is K. Can you tell me what is N? What is the sample size you want to choose? What is the sample size? Yes, what is the sample size?
5.
5, exactly. ये आपको 5 notes can be chosen जो है लिखा हुआ है, यहाँ से आपको समझ में आना चाहिए. So here N is equal to 5. And how many types of objects you have? That is your K. K types of objects हमने कहा था ना, R1, R2, Rk. So how many types of notes you have now?
7 types.
Yes. So once you
7.
get these two numbers, it is easy to find the answer. Okay, you need to identify the situation. See the language carefully. Indistinguishable means identical objects. And the order in which notes are chosen, it is immaterial. Okay, and therefore number of ways of choosing 5 notes is equal to N plus K minus 1 Cn. Any one formula you can use. Okay, so N is 5, K is 7. So 5 plus 7 minus 1, that is 11C5. Okay, 11C5 is 11 factorial upon 5 factorial into 6 factorial. So you can simplify this 11 into 10 into 9 into 8 into 7 into 6 factorial upon 5 into 4 into 3 into 2. Excuse me. So 6 factorial goes. This 5 and 2 cancels with 10. This 4 is cancelling with 8. 3 is cancelling with 9. So you have 11 into 42. 462 ways are there to select. So it may happen that you may get all 5 notes of one type only. It may happen. It may happen that you get one note of each type. It may happen. Now there are 7 types, right? So it may happen that one note of each type you will get and 2 types you will skip. So there are again different combinations. Do you understand the question? Do you understand
Yes,
it?
ma'am.
One more now for you. A simple one. A library has at least 6 copies. At least means minimum 6. Okay? At least 6 copies of each of the same book on algebra, geometry, and calculus. In how many ways can we select 6 books? So we don't know the actual number of each type. Do you understand this? Right? Did we
Yes.
actually use that number? In the previous example also, what we had was, see, a bag contains rupee 1, rupee 2, the type of the notes of each denomination being more than equal to 5. Okay, so we don't know the actual number, how many notes are available. We don't know that actual number, but minimum 6 copies are available of each type. So what is N here? How many books we want to select? That tells you.
6.
Yeah. Question. So N is 6. What is K here?
3.
3. And therefore the answer is number of ways of selecting 6 books equal to 6 plus 3 minus 1 C6. So it is 8 C6. Right? And what is 8 C6? 8 into 7 into 6 factorial upon 2 factorial into 6 factorial. This is the formula. So it is 28. Okay. Now we are left with 2 more formulae from this chapter only. Okay. So I think we can do the next one quickly. Permutations with indistinguishable objects. What are permutations?
Order arrangement of an object.
Ordered arrangement means, yeah, arrangement, right? Now if I write the word dear, then how many ways you can arrange the letters of the word dear? DEAR. There are 4 letters and 4 places you have. So how many ways are there to arrange this? First place has 4 choices. Second place has 3 choices. Third place has 2 choices, and last place has 1 choice. So there are 4 factorial ways, right? You can have 4 factorial permutations, that is arrangements of these letters, right? They may be meaningful, they may not be meaningful. It may be read, it may be dare, it may be RADE, something like that. Okay, are you getting it? But here no letter is repeated, all the letters are distinct, isn't it? Right?
Yes, ma'am.
But if I change now this, what will happen? See, if I change, if I write dear, DEER, then how many ways are there to arrange the letters in this? You can have this, right? This is one arrangement. Now I will write this D here and this R here only, but I will interchange these E's. मैं इस E को यहाँ पे लिख रही हूँ पहले और इस E को यहाँ पे लिख रही हूँ. Does it give a different arrangement? Will you consider this as a different arrangement?
No.
ये E को मैंने यहाँ पे लिखा, इस E को मैंने यहाँ पे लिखा, नहीं ना? E is E, no? They are identical, they are indistinguishable. You understand me? And therefore this is not a different arrangement. Okay, if I write EDER and again I will put this D and R same, and this E I am writing here and this E I am writing here, will it give me a different arrangement?
No.
No. So at a time, so those many duplications we need to avoid. मतलब ये दोनों जो है, इन दोनों के जो अरेंजमेंट्स है, they will give us the same answer. Okay, 5 minutes में meeting end होगी girls, but please join again back as I want to take your attendance. Okay, so we want to see such type of arrangements where there is repetition of the letters. The letters are identical. A is identical with itself, right? So if you have a word, say meeting. So here E is repeated. If you have a word, say Mississippi, there are so many letters which are repeated. So we want to find out permutations. So the duplications we need to avoid, okay? The among themselves. So ये SS block मैंने यहाँ पे रख दिया या ये यहाँ पे रख दिया. It will give me same arrangement, okay? So I think we can finish the statement today. Write the statement. The number of permutations. The number of permutations. So permutations means arrangements. Every time you please remember this. Of n objects. Containing. So total number of objects is n. Out of which containing n1 indistinguishable objects of type 1. n1 indistinguishable. Indistinguishable means you cannot distinguish. You cannot classify. n1 indistinguishable objects of type 1. n2 indistinguishable objects of type 2. And so on. nk indistinguishable objects of type k. The number of permutations of n objects containing n1 indistinguishable objects of type 1, n2 indistinguishable objects of type 2, and so on nk indistinguishable objects of type k is n factorial upon n1 factorial into n2 factorial and so on up to nk factorial. Getting it?
Yes, ma'am.
Okay. So it is very easy. Let me just quickly show you the proof. We will take it in detail. What happens, see, suppose I have n places. Okay. First, I will choose the first object which is appearing n1 times. So I will place that object n1 times out of n places. So that can be done in how many ways? nc n1 ways, right? You are choosing n1 places for that, right? जैसे कि मैंने ये कहा dear ये word था, dear. Okay, so there are 4 places. How many e's are there? How many e's are there? How many e letters we are having in this word? 2 times, right? Girls, are you there?
Yes, ma'am.
So what I will do, out of these 4 places, I will choose 2 places first of all for the letters E. 2 letters E. So how many ways I can choose 2 places out of 4 places? 4 C2 ways. Do you understand it?